Okay, question 38. Again, this is organic chemistry. So this is looking at what happens when you add an excess of concentrated sulfuric acid to these alcohols, basically, okay? The fact that they're cyclic compounds doesn't really make a huge difference here, okay? You just need to know what happens when you dehydrate alcohols. And when you dehydrate alcohols with hot concentrated sulfuric acid, you make a double bond, okay? So let's have a look at what happens. Okay, so just to help with the background theory, I've just copied in a very simple dehydration here. So here we've got ethanol, and you can see that the concentrated sulfuric acid has essentially removed the water there, okay? And in doing so, a double bond has been created between the carbon that was attached to the hydroxy group and the neighboring carbon, okay? So that's really important. So perhaps to make things a little clearer, then we're going to add some carbons in here. So we'd have a carbon there, wouldn't we? We'd have a carbon there and a carbon there. Here we'd have a carbon and a carbon there. I'm just adding the carbons that are going to be important for us working out what the products are, okay? So we'll have a carbon there, we'll have a carbon there, we'll have a carbon there, we'll have a carbon there. Carbon, carbon, and here, carbon, 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 okay? Now, the question asks, on heating with the sulfuric acid, which is going to produce only one product, okay? Only one product with this formula, okay? So let's have a look at what would happen if we start to remove water. So we're going to do this in a simplified way. Essentially, in this reaction, you'd get rid of the hydroxy group there, and you'd form a double bond here. Okay, I'm not going to draw on the carbons, the hydrogens that would be there, sorry. You'd get rid of that hydroxy group there, and you'd form a double bond there, or you'd form a double bond here, okay? But it doesn't really matter if the double bond is formed here or here, because they're still going to be exactly the same compound. So there's still only one product there. So in option number one, yes, you would form only one product. So one would be correct. Let's look at option two. Okay, in this option, you would form a double bond here, getting rid of the hydroxy group there, and you would form a double bond here. Now you may ask, well, why couldn't you form a double bond there? Well, you can't, because the carbon there already has its 4 bonds, okay? So this would produce only one product too, okay? So this is correct. Now let's look at this final option here. Okay, so we'd get rid of the hydroxy group there, we'd form the double bond there as the water is being removed, and we'd form a double bond either there, or we'd form a double bond there. So we could have that option there, or if I try to erase this without making a mess, or we could have this option here, okay? In other words, those two products are different. So this one here could form 2 different products, meaning that this would be incorrect, okay? So the correct answer is going to be 1 and 2 only. Both of these are correct. Okay, so it would be B. Hope that's helped.